Today we are going to look at the PSW and the stack memory of 8051. Before we discuss in detail the PSW and the stack memory of 8051, I would like to explain about the 8051 RAM organization. The basic 8051 microcontroller consists of 256 bytes of RAM, which are partitioned as 128 bytes of GPR and the other 128 bytes of SFR. And if you look at the memory locations reserved for the GPR, that is 00H27F represents the GPR, and 80 to FF it represents the SFR. Altogether from 00 to FF it is going to represent the RAM, that is random access memory. Now the GPR is further partitioned into three sections, namely register banks, bit addressable, and scratch pad. Now out of 128 uh, bytes of GPR, so 32 bytes we have reserved for the register bank, 16 bytes of bit addressable, and the remaining 80 bytes we have reserved for scratch pad. And the address are uh, represented as 00 to 1F for register bank, 20 to 2F, that will make 16 bytes, so it will be representing the bit addressable, and 30 to 7F it is going to represent the scratch pad. Again, the register banks are further partitioned into four register banks, namely register bank 0, register bank 1, register bank 2, and register bank 3. And the total address of register bank, that is 00 to 1F, are further partitioned as 00 to 7, it is going to represent the register bank 0, A to F register bank 1, 10 to 17 it is going to represent register bank 2, and 1A to 1FH memory location it is going to represent the register bank. This is how we are going to construct the register bank. So this is one memory location. Like this we need to have 8 memory location that will constitute register bank 0. The physical addresses is represented for register bank 0 from 0 to 7, and these are the symbolic names used to refer the memory locations. The naming convention followed are from R0 to R7. Likewise, we have the next memory location after 7, 8, 9, A up to F, total 8. Now these 8 memory locations will represent register bank 1. Right, after F 10 to 17 it is going to represent register bank 2. Now if you look at the picture, that the same naming convention symbolic names are been followed, that is R0 to R7. If we give access to 32 register simultaneously, then we require 5 bits to represent the register name, that is R0 to R31. If we have distinct register, 32 distinct register if we have, that is R0 to R31, then 5 bits are used to represent the register names. That will increase the instruction size. So to restrict ourselves to take lesser bits to represent registers, so what we have done is the register banks we have classified into 4 of each 8. So at given point of time only 8 registers are being used, are available for the programmer, but you can switch to these register banks with the help of PSW register. Now the stack memory starts at the 8th memory location, that is it starts at the register bank 1, the starting address of the register bank 1. Either you can select it as an register bank, or you can refer it to it as the stack memory. The stack memory starts at 8 and the stack pointer starts points at the 7. Why it is 7? because the two primitive operations we can define for the stack memory is, one is push operation. The push operation is defined as this stack pointer will be first incremented by 1, and then the value will be copied to the memory location whose address is pointed by stack pointer. And the other primitive operation is the pop instruction. And what is pop defined? So pop is defined as read the value of memory location whose address is pointed by SP, and then the value of SP will be decremented by 1. Now where is this stack pointer located? So stack pointer is located in SFR, and the width of this SFR is 8-bit. So one of the SFR location is stack pointer, and the default value will be 7. It always refer at the 7. You can change it to any other address as the programmer uh, uh, needs to change the stack memory, but the default will be at the stack pointer will be 7. To represent that the stack memory starts at 8, the first value will be stored at this 8th location of the GPR. And remember, the stack pointer width is 8-bit in size, and the maximum value it can hold is FF. Can we store the maximum value stack pointer to FF? So we should ensure that the stack pointer should not cross right 1F, right? Because after 1F, 20 to 2F it starts with bit addressable, and scratchpad we have 30 to 7F. So if you want large enough stack memory, then stack pointer default value you change it from 7 to 30, so that the stack memory can grow up to 7F. The best to use the stack memory is the default, that is stack pointer points at 7 and it starts at 8, and from 8 to NF it can be used as what, stack memory. And we have 8 registers, we have 16 bytes of bit addressable and scratchpad. So this is the way to make use of the stack memory along with the registers, bit addressable and scratchpad. And the next SFR register is PSW, that is program status word register, and PSW is a part of SFR. We are going to discuss in detail about the program status word register. So the program status word register structure is as follows. It contains 4 status flag bits, namely carry flag bit, auxiliary flag bit, overflow flag bit and parity flag bit. And we have 2 flag bits that is used to select the register bank. So totally we have 4 register banks. So 2 bits are required to encode 4 register banks. That is 00 will represent register bank 0, 01 will represent the register bank 1, 10 register bank 2 and 11 register bank 3, right? And this F0 and user defined, right? So user definable bit it is reserved here, and this is also reserved for the user purpose. Since PSW is a bit addressable register, so each bit separately we can access. So 0, 1, 2, 3, any one particular bit of this PSW can be accessed. So therefore it is named as bit addressable register. If the register is byte addressable, you cannot access a single bit of that register. Since PSW is a bit addressable register, we can access. Now what are the symbolic names for this? So the symbolic names in assembly language, we need to represent this address as symbolic address as PSW.0. Likewise, PSW.1, PSW.4 and goes on up to PSW.6.